Well, this video is for Math 112, section 3.4. So this is a second assignment on solving trigonometric equations. Some of it, the first couple problems will be review, and then some of it will be a little bit different, but the ideas will be fundamentally the same. So I'm not going to go through the explanations here. Like I said, most of the ideas we've talked about before. So let's go ahead and just start working through the even-numbered problems here. Problem 2, we've got 4 cosine squared theta plus 4 cosine theta equals 1. So the first thing we want to do, if we're going to be using the quadratic formula, is to put this in standard form with everything on one side set equal to 0. And then we can get answers for what the cosine of theta should be. And then we'll figure out what theta is. All right, let's see here. A is 4, B is 4, C is -1. So let's go ahead and run that through the quadratic. That gives us solutions of cosine theta is approximately 0.2071, or cosine theta is approximately -1.2071. So this one is going to have no real solution, and you don't really necessarily need to write that down because we will get solutions from this over here. So let's do the, inverse cosine. Let's see, I'm still in radians. I was doing something over the weekend where I needed radians. Okay. Inverse cosine there is going to be 78. Let's see, we've been rounding to, I think, 1/10 of a degree, even though it's not in the instructions there. So I'll stick with that. So that's going to be 78 degrees. And again, remember our little ASTC diagram. So the cosine is positive in the fourth quadrant. If we've got a reference angle of 78 degrees in there, and that's going to make the angle coming around from the other side 282 degrees. And so that's going to be our second solution here. 282 degrees. And there we go. Okay? So like I said, we don't really need to worry about this too much over here. Just provide the solutions that actually do work, and we'll be all set. All right. Else? Well, number 4. Number 4, we've got the cosecant squared beta plus 4 cosecant beta minus 10 equal to 0. Okay, so this is in standard quadratic form already, and we can just run it through the quadratic formula. Let's see, A is 1, B is 4, C is -10, and so we get cosecant beta could be 1.74166, or cosecant beta could be approximately -5.74166. So then from there, we need to take the reciprocal, right? Because we don't have any inverse cosecant functions on our calculator. So we will use the sine of beta. It is going to be approximately, let's see here, 1 divided by that root, 0.574166 or so. And so then we'll take the inverse sine of that, and and this comes out to be just about 35 degrees. Okay? We'll come back and find another angle for this solution in just a minute. Let's go ahead and work on this one. Sine of beta is going to be 1 divided by the other root, so negative 0.174166. We'll take the inverse sine of that, and that gives us the value of beta as a negative angle. So for values between 0 and 360, we'll have 350 degrees in the fourth quadrant. Let's see here. All right. Let's see. Okay, so in the fourth quadrant, and then also in the third quadrant, we'll have a 10-degree reference angle, so that'll be 190 degrees. Over here, we've got a sine with a positive value here, so that's going to be 35 degrees in the first quadrant. And then, oh wait, the sine's going to be positive in the, the sine's going to be positive in the second quadrant. There we go. 35 degrees and 35 degrees. So 180 minus 35 should be 145 degrees. So there's our four solutions: 35, 145, 350, and 190. And those were all 0.0. Okay. So, and actually these were as well. So we didn't really need to round off to the nearest tenth because that was always 0 in those cases. All right. Now let's keep moving with this. Let's see. Okay, problem 6 I think is very similar. I don't think we really need to look at that one. Problem 8 is where problems start to get a little bit different. So let's take a look at that one and talk about how to approach it. Here we've got cosine squared alpha plus 4 equals 2 sine alpha minus 3. Okay. So one of the new things that we're going to talk about in this section 3.4 is what happens if you have different trigonometric functions in your equations. We'll look at a couple of methods that we can use to try to solve equations like this. And the idea is to use identities, right? Because we know from our consideration of trigonometric identities that cosine squared of alpha is the same as 1 minus sine squared of alpha. So you notice that this is a sine, but this is a cosine squared. So that prevents us from using the quadratic formula. It's like you've got an x squared plus a y in there, okay? But what we can do is replace that cosine squared with 1 minus sine squared, and then we'll collect everything on one side. Let's see here. So this will be sine squared alpha plus 2 sine of alpha. This will be 1 and 4 make 5. Subtract that over here, and that'll be minus 8. Okay? Alright, so now we've got everything over on one side of the equation. And let's go ahead and run this through the quadratic. So A is 1, B is 2, C is negative 8. And it looks like this one will not have any solutions. For one thing, it's factorable. That doesn't have to do with whether or not there are solutions. But what I'm getting here as solutions are sine alpha equals 2 or sine alpha is negative 4. And so here we've got no real solutions across the board, okay, for the entire equation. And so we could just say no real solutions. Okay, let's see here. Well, let's keep going. Let's look at another one that maybe will have some solutions. Problem 10. sine squared theta equals 2 cosine theta plus 3 cosine squared theta. Okay, so this is sort of the opposite of what's happening in problem 8. Here we've got a cosine and a cosine squared. That's great to go ahead and get us started if we wanted to use the quadratic, but this really prevents us from doing that. So we'll do the opposite of what we did in that last problem. Here we'll replace the sine squared with 1 minus cosine squared. And then move everything over to one side. So add the cosine squared and then subtract the 1. So over here we'll have 0. Here we'll have 4 cosine squared theta plus 2 cosine theta minus 1. Okay, so let's run this through the quadratic and see what we get. A is 4, B is 2, C is -1. And let's see here. So our solutions for cosine theta is approximately 309,017, or cosine theta is approximately -0.809017. Okay, let's take the inverse cosine. There we go, that first root, and that's going to give us exactly 72 degrees. Let's see here. So the cosine was positive. That's going to be the first quadrant. So then in the fourth quadrant, we need to do 360 minus 72, and that'll be 288. And then this one over here, inverse cosine of that root, is going to be 144. And let's see here. So the cosine is negative in the second and third quadrants. So that, let's see, what is that reference angle in there? That is going to be 36 degrees. And so we need to do 180 plus the 36. And that'll give us 216. Okay, so we've got 4 solutions here: 72, 288, 144, and 216. All right, so hopefully this is a good introduction to this concept of replacing one of these expressions with an equivalent expression that involves a trigonometric identity, so we can have everything be in the same trig function. Which one it is doesn't really matter, but what's important is that it's all the same, so that we can solve this equation, whether it's quadratic or not. It's just really helpful to have a single trigonometric function to be able to solve one of these equations. Okay, problem 12 is another good example of this. Here we've got 3 tangent squared x equal to secant x plus 2. Okay, so here, again, this is tangent squared, this is secant, and so we can't use the quadratic formula. So the idea here, now almost all of these identities involve the squared part. So that's going to be really mostly the only thing we're going to be able to replace is going to be that expression that's squared. Okay? So we should try to match it to whatever's here. Okay? So this one we don't really have an identity for other than that it's 1 over the cosine. And so the idea here is that if we can replace this with something involving the secant squared, then that'll match the secant here, and we'll be able to solve this using the quadratic formula. So that's our goal here. is to look for the thing that we can't replace and try to match it to something else that we can replace, right? So we see this, and the idea is, okay, do we have anything for the tangent squared that involves the secant squared? And the answer is yes. Tangent squared is secant squared minus 1. Okay, I'll go ahead and put the 3 in there because that's going to have to get distributed into the parentheses. So we're going to have the 3 outside the parentheses, secant squared x minus 1, and over on the other side, secant x plus 2. So we'll go ahead and multiply through 3 secant squared x minus 3, and then we'll move these to the other side. So this will be equal to 0. We'll have 3 secant squared x minus secant x minus 2. And that's probably going to be factorable. I'll go ahead and run it through the quadratic anyway. See what we get. Let's see, 3, negative 1, negative 2. Yeah, so what we get here is secant x equals 1, or secant x is negative 2/3, or negative 0.6 repeating. Okay, so again, we're working with a reciprocal function, and so we want to rewrite this as cosine x is the reciprocal of 1, which is still 1. Over here, cosine x is going to be the reciprocal of negative 2/3, which is negative 3/2. No real solution, right? Because this is less than negative 1. So over here, cosine x equal to 1. We can do that on the calculator. So take the inverse cosine of 1, and x is equal to 0 degrees. So that's our answer, is 0 degrees. Sometimes people get confused by the answer being x equals 0, saying that that means no solution. No. This means no real solution because there's no angle whose cosine, no real valued angle whose cosine is negative 1.5. But over here, there is an answer. The answer is 0 degrees. Okay? All right. Let's keep going with these. Let's see here. Problem 14, we've got cosine 2x minus 3 sine x minus 2 equals 0. Okay. So again, you can see we've got the sine here, so we want an identity for cosine 2x that involves the sine function. Now, we've got our choice, right? We could use cosine squared minus sine squared, but then we just have to replace that cosine squared with 1 minus sine squared, and then that would give us the identity that we really want for this problem, which is 1 minus 2 sine squared x. 1 minus 2 sine squared x. And then that matches up with the sine x that we already have there. I like to keep things positive. There's nothing wrong about having these negative coefficients. I just like to keep everything positive. So I'm going to move everything over to the other side. Let's see, that'll be minus 1. So then we'll have 0 equals positive 2 sine squared x, positive 3 sine x, plus 1. Okay, and then I think this looks factorable as well, but again, I'll run it through the quadratic. 2, 3, and positive 1. Yep, so we get sine x could be negative 1/2, or sine x could be negative 1. Okay, let's see. We'll go ahead and do this one. Inverse sine of negative 1. Actually, this is probably going to return an answer of negative 90. Yep. X is negative 90. And so that means we're interested in the angle that's coming around from the other direction. This is 270 degrees. That's the angle that we want because that's between 0 and 360. So, give us an answer of x equals 270. Over there, sine being negative 1/2. So that's going to be in the third and fourth quadrants, 330 and 210 degrees probably. So let's see. Inverse sine negative 1/2, negative 30. Okay. So then again, we look at that negative 30 and treat it as a reference angle. Alright. Then the angle coming around from the other direction is 360 minus 30, or 330 degrees. And then if we put a reference angle of 30 degrees into the third quadrant, right, because that's where the sine function is negative, right? The sine is negative in the third and fourth quadrants. So over here it'll be 180 plus that 30, which is 210. So 210 degrees, 330 degrees, plus that 270 degrees. Okay. Let's see what problem 16 looks like. Cosecant theta plus 5 equals 2 cotangent squared theta plus 2. Okay, so again, we've got the cosecant and the cotangent in there together, so that prevents us from using the quadratic formula to solve this. The idea is to replace the squared one with something that matches up with this term right here, the cosecant, right? And we've got an identity that says that the cotangent is equivalent to cosecant squared theta minus 1. So, if we go ahead and make that substitution, then let's see, this will be 2 cosecant squared theta minus 2 plus 2. So that'll make 0 here. And then we'll move these to the other side. That'll put a 0 here. 2 cosecant squared theta minus cosecant theta minus 5. Now that one does not look factorable. What are we going to get from the quadratic on this one? Let's see, A is 2, B is negative 1, C is negative 5. Okay. Cosecant theta, approximately 1.85078. Or cosecant theta could be negative 1.35078. Okay, so again, we're working with a reciprocal function, so we want to consider what the reciprocal is. The reciprocal of the cosecant is the sine function. Sorry about that. There we go. And so then we want 1 divided by that root, 1.85078, 0.5403 approximately. And then this one over here, 1 divided by that root, negative 0.7403 or so. Okay, so then we want to take the inverse sine of that function, or that number, that value right there, That gives us 32.7 degrees. 32.7 degrees. And the sign is positive in the first and second quadrants. And so this angle right here is going to be 180 minus 32.7, 147.3. Let's see here. 147.3. Okay. This one here with the negative sign, so that's going to show up in the third and fourth quadrant. So let's see here. Inverse sine of negative 0.7403, negative 47.8 degrees. So then what we need to do is use that 47.8 as a reference angle in both the third and fourth quadrants. Throws 360 minus 47.8, 312.2. And then the other one will be 180 plus 47.8, 227.8 degrees. Okay, so that's it for section 3.4, and that's it for chapter 3. In chapter 4, we'll come back and talk about some more uses of trigonometry in solving applied word problems. As always, if you have any questions, please let me know. Thanks.